This video is for the assignment for the AP Classroom from Tuesday, 3/17. This was a 6.1 practice. 6.1 extra practice. Okay, our first question on our homework was dydx, or on the AP Classroom was dydx equals xy. Y is equal to plus or minus this. Let y equal f of x be the particular solution. Which of the following is an expression for f of x in its domain? Okay. So first of all, we could solve this if we wanted to separate it, but the already gives us a solution. I'll solve it for you anyway, just as a review. Let's take this part and go and separate the variables. So we got y dy equals x dx. So that was the separate part. Integrate next. You got y squared over 2 equals x squared over 2 plus c. Once you do that, now you want to solve for y, so y squared equals x squared plus c. We're not changing the c to 2c because 2 times the number we don't know is still a number we don't know. Now, taking the square root, we got y equals plus and minus square root of x squared plus c. So we can see we didn't actually need to solve this because they gave us a solution. But I just wanted to review how they got that anyway. Now, if there's an initial condition of f of negative 5 equals negative 4, well, the way we can do that is we can go ahead and plug in negative 4. If we plug in negative 4 here for y, and negative 5 here for x, we can go ahead and get c is equal to negative 9. So that means our equation with the value of c is going to be y is equal to something x squared minus 9. Okay, so that's number 1. Now, the plus or minus, the way I know that, and I think I mentioned it in the video before, is anytime you're given a y value, that y value needs to be negative when we evaluate. So my answer should be this. A negative root. Okay, so that's my answer. Y equals negative square root of x squared minus 9. If I look at my options here, it can only be C or A. Now, I actually don't like either of these answers because what shape this makes, well, let's take a look at this on the graph. Perfect. Okay. So here's how I would do the domain here. It looks like the graph had a domain for where x is not only less than negative 3, but also greater than 3. And I feel like AP might have had a wrong answer on this one. So let's do some math here to see what the right answer is for the domain. We want x squared minus 9 to be greater than 0 for all x. Because if we have anything that's technically greater than or equal to 0, but if we have any value that cannot be plugged in the root, the values that we can't have are negative, which means we want all of our values to be positive here. So, x squared minus 9 is greater than 0. Let's do this. Okay, we get x squared is greater than 9. When we take the square root, when we take the square root of an x squared, we get an absolute value of x. So we get absolute value of x is greater than 3. And what that translates into is that x is greater than 3 or x is less than negative 3, which is exactly what we want. I would actually argue that the answer should be C and not A. So I'm going to remove this and move it down. The answer they originally had was C. I'm sorry, it was A, but the answer looks like it's actually C. And I verified this graphically, so I know I'm correct. I'm just double checking what AP had, and yeah, this is incorrect. And they're wrong. So again, the answer should be C for this one. I'll go back through and check to see if anyone got C the first time. Let's go on and do number 2. Hopefully there were no other mistakes. This is our first time using AP Classroom, and from now on I'll vet the questions and make sure that I kind of did already, but I didn't realize there'd be wrong answers in here. Okay, so here, let's go and do this one. Y dy equals x squared dx. Let's go and integrate both sides because we have a solution to a differential equation. We get y squared over 2 equals x to the cube over 3 plus c. We could multiply it by 6 to get rid of that denominator. So 6y squared equals 2x squared plus c. So again, I just multiplied everything by 6. And then, dividing by 6, and just checking something else here. Okay, and when you divide by 6, we got y squared equals x squared over 3 plus c. Now let's go and get the initial condition. So when we plug in 3, so we get negative 2 for y, so negative 2 squared equals 3q squared over 3 plus c. Let me just check the work on that and make sure that's correct. Yeah, negative 2 is y, and 3 is x. Now, I do have one small mistake here. I do want to make sure that I change this to a cube. Okay, that looks good. So now I get 4 is equal to 9 plus c, which means c is equal to negative 5. So now I can go ahead and do y is equal to plus or minus square root of x cubed over 3, and then minus 5. Now I'm already noticing that this answer is not in the answer choices. So I'm going to reevaluate my approach here. Instead of multiplying by 6 here, so I'm going to take everything off because my answer is not on here. Instead of multiplying everything by 6 and getting too fancy, I'm just going to multiply by 2. So it's interesting that if you don't, it's interesting that if you don't actually just solve directly, you will get a different answer. So watch this. Now I'll get the actual answer that they have. So y is equal plus and minus the square root of 2/3 x squared plus c. Now when I go ahead and do this, then I get y squared, when I plug in the point is what I mean. When I plug in that initial condition of negative 3, 2, I get negative 2 squared equals 2 times 3 squared over 3 plus c. And again, it should be 3 cubed. And then if I do that, I get 4 is equal to, this looks like it's going to be 18 plus c, which means c was equal to negative 14. And that means that y is equal to a plus or minus square root 2/3 x squared, and then minus 14. Now I just need to check whether it's a plus or minus here. And again, since my y value is negative, it's a negative value, I need a negative root, so my final answer should be the negative. And that does give me the original answer, which was that. Now again, what was fascinating here for me is how wrong my answer would have been if I would have multiplied by 6 right away. And that I'll check out on my own. Maybe I did something wrong. I might have done something wrong originally, because I don't think I brought down a 2 in the original work. I'm just going to undo this to make sure that that's correct, because then I'll go faster in some of these problems. Yeah, I just didn't bring down the 2. This is what happens when I do work late at night. I had 2 problems here. Wow, I had a lot of problems wrong there. Okay. Now that makes me wonder how the other problem was. But I'm pretty sure I'm around the other problem because I entered in the calculator. Okay. So, again, our answer here was this. I'm sorry that I wasted your time with the other incorrect way of doing that. Let's try to do something a little bit more correct this time. Okay, so we're doing the same process again, so let's go and do 1 over y squared dy, just to separate the variables. Then let's go and integrate both sides. You get x plus c on the left, on the right. You get negative 1 over y on the left. The reason is the integral of y to the negative 2 dy. You add 1 to each exponent, you get negative 1. Y to the negative first divided by negative 1, which is negative 1 over y. Let's go and solve, because we could plug in the initial condition at any time. So let's go and do negative 1 over 1 equals 1 plus c. This looks like c is going to be equal to negative 2. So now, let's go and rewrite our equation. So now we're going to negative 1 over y equals x minus 2. And to solve for y, what I do is I do this fancy thing, which is just switches these two. In other words, I multiply by y and divide by x minus 2. So all in one step, I get negative 1 over x minus 2 equals y. So here's my equation. Now, negative 1 over x minus 2 doesn't look like either of these answers. Sorry for the abrupt interruption, but my daughter woke up and I had to help her out. Okay, so now divide both sides by negative 1, and we'll get negative x plus 2, or 2 minus x. And that's what one of the answers is. Now it says, which one do we want? Well, because we want f of 1 equal 1, and the graph of 2 minus x looks like this. So 2 minus x is vertical asymptote of x equals 2. And then because the x is negative, we're going to have something like this here. Well, where 1, 1 is on this side. And because 1, 1's on this side, we want x is less than 2. We cannot have both values because, again, the initial condition for this is on the left side of the vertical asymptote, not on the right side, which gives our answer of D. Okay, which of the following equations could be a slope field for the differential equation? We give D here, so let's just eliminate y cannot be C, B, and A. Let's start with B. For B, it looks like we have slopes of 0, and that's always my go-to, as I always like to see what slopes there are. My slopes at 0 are anywhere where y equals 0. But if I put anywhere where y equals 0, whenever I put y equals 0, I actually get out x squared. And I don't get 0, which is what I was supposed to get, so it cannot be B. I hope that makes sense. When I plug in y equals 0 here, I expect a slope of 0 out. If I don't get a slope of 0 out and I get something else out, then it cannot be this possible one. That's kind of the same thing here. I noticed that, and I did this in the video for the notes, that there's this y equals negative x. And when y equals negative x, dy y prime is supposed to equal 0. Okay, so let's see what happens here if we get y equals negative x. We get x squared plus negative x. And again, that's not equal 0, can't be A. And I'm looking here, and I don't really see 0 slopes. So kind of interesting. And by the way, I can't separate and solve this, so there's no way I can do that. Like, there's no way I can actually find what the original function is, because this is one called a not separable one. So let me just write that out for you, because I don't know if we've covered that entirely. But this is a not separable differential equation, which means you would need other methods to solve it that you would learn at a later time, not in this. Okay, so for the last one between these two, I'm just going to look at this purple. So for each one of these, and the one on the right looks like it's a really steep slope, the one on the left looks like it's kind of a flat slope. So if I plug in something like x equals -2 and y equals 2, which is the coordinates at that point, mostly, then I should get a really big number, and that's the answer that I'm going to go with. So when I plug in -2 squared plus 2 versus, well, if I plug in -2 squared plus 2, I get 6. And 6 is a very steep slope, which is why D would be the answer. And if you're wondering, could I just plug in a number each time? Absolutely. And sometimes that is the quicker way of doing the problem, but I just wanted to give you other ways of solving the problem. If plugging in points was not always that good for you. Okay, number 5. Which of the following is the solution to differential equations? So let's go and solve this one. I got to separate the variables first. I got 1 over y squared dy equals 5 dx. I integrate. This one we did before is -1 over y equals 5x plus c. Now I'm going to plug in 0, 3. So I get -1 over 3 equals c, because 0 is x. Let me erase that and clean that up. Okay, so now I end up getting -1 over y equals 5x minus 1 over 3. Multiplying both sides by 3, I get -3 over y equals 5x minus 15x minus 1. Oh, just made a terrible mistake. 15x minus 1. And then, again, what I did in the last video is the last couple problems is I switched these two, multiply by y and divide by 15x minus 1, and that gets us -3 over 15x minus 1. It looks like all of my answers from what they give me are off by a negative, which is why D is your answer. So divide both sides by -1, and you end up getting D as your final answer. For the next one, 6, which of the following is the solution to the differential equation? Let's do it again. I'm going to go ahead and multiply by dx on both sides, sort of. So dy is equal to sine of x dx. Then I'm going to go and integrate both sides. I got y is equal to -2 cosine of x plus c. That's my general solution. I'm going to use the initial condition pi at 1. So 1 is equal to -2 times the cosine of pi, which is -1 plus c. So c is equal to 3. And then I'm going to go ahead and rewrite with c, which is y equals -2 cosine of x plus 3. It looks like I made a mistake. Let's check my work. Yep, I made a mistake. When I multiply by 2 here, I subtract 2, that's a -1, which means this should be -1, and E is my answer. Oh my gosh, Mr. Lake, that was bad. Okay, last one, but again, I'm also doing this at 1:45 in the morning, so I'd probably be better during the day. Or I'm just making excuses. For number 7, I get, again, when I separate the variables, I get 1 over y squared dy equals x dx. And if you're wondering why I have to keep doing 1 over y squared, it's because I really, really want you good with that one. So -1 over y equals x squared over 2 plus c. I'm plugging in 1 and 2, so let's go and do that. To solve for c, I'm going to get -1 over 1 equals 2 squared over 2 plus c. It looks like it's going to be 2 plus c. I won't take any shortcuts this time. So c should be equal to -3. And then, let's go ahead and do that again. So I get -1 over y. Just plug in c. So -1 over y equals x squared over 2 minus 3. By the way, I didn't make a point of this before. If it seems like you are solving for y here first and then plugging in to solve for c, either way should get you the answer. This is just my natural way of going about it. I can multiply both sides by 2 just to get rid of that x here. The fraction here I don't really want, so I'll multiply by 2 on both sides. and I get negative 2 over y is equal to x squared minus 6. And again, when I switch, I get y is equal to negative 2 over x squared minus 6, and all of my signs differ by 1 for d, which is why d is my answer. And then for the final one, let's go and do this one. I'm going to get y dy equals 4x dx. Let's go and integrate both sides. I get y squared over 2 equals 2x squared plus c. And then I'm going to now get negative 2, plugging in negative 2 and 2. I get negative 2 squared over 2 equals 2 times 2 squared plus c. Let's see what we get here. We get 2 and an 8 plus c, which means c is equal to negative 6. So now I'm going to go ahead and plug in c. I get y squared over 2 equals 2x squared minus 6. And then let's go on and solve for this now. I get y squared is equal to 4x squared minus 12. And then take the square root of both sides. Oh, I need to go back to the first problem. I know what I did wrong. I know exactly what I did wrong. Okay, and I'm going to get y is equal to, okay, please stop doing that. I'm going to get y is equal to plus or minus the square root of 4x squared minus 12. Now I have to look and see which one this could be. 4x squared minus 12, I need a negative value because I have a negative y value. So that negative y value tells me I need to have a negative y value here. So my final answer is y is equal to the square root of 4x squared minus 12. Now, which value am I going to pick? Am I going to pick, I'm sorry, it's a negative. So I have two options here. I have B and I have C and I have E. So now I want to do, I know I can have 4x squared minus 12 to be positive because that's what I need. When I add 12 and divide by 4, I get x squared is greater than 3. And when I take the square root of x squared, I get x is greater than the absolute value of x is greater than 3. But my x value is 2. And the square root of 3, I didn't put the square root here, but I said it. The square root of 3 is about 1.7. So I'm not sure why they have 1.5. Oh, no, never mind. Hold on. I'm being silly. So again, the square root of 3 is about 1.7. So I need a number that's going to be greater than 1.7. Because I have an x value of 2. I have the x value of 2 here, so I need a number greater than 1.7. Which is why C is my answer. I need to go back to do number 1, please. Because I realized I made a big mistake here. When I said the absolute value of x is greater than 3, that's true. I also noticed, though, that my x value is negative 5. And because my x value is negative 5, I actually cannot have both of these as my answer. So that's wrong. I need it to be only one or the other. It cannot be both functions. It can only be one or the other, which is why my answer was correct as A, because negative 5 is less than negative 3. So that was my answer for number 1. Thanks for watching, guys, and sorry with so many mistakes.